Hello guys, so today we are going to see a mock Vita problem of Fibonacci prime. So we'll start now. Yeah. So the question or the problem statement is find the prime numbers between n1 and n2, make all possible unique combinations. We have to get list of prime numbers. We have to get smallest and largest number. Consider smallest, okay, and then we have to generate a Fibonacci series, and then we have to print the number. So if you want to read the question, you can just pause the video. Okay, so these are the constraints. Our first number will be from 2 to 100. Okay, and the difference between them will not be like greater than 35. So the input format is will get two numbers which are space separated. Okay, and we'll also get output, means we'll generate the output. So these are the constraints. So now we'll see the example. Okay, so our input is 2 and 40. Hmm. So first of all, what we have to do is generate the list of all the prime numbers from 2 to 40. Then we have to get combination of two numbers like 2 3, like here 2 5. Okay, so two numbers. Okay, we'll get this. Okay, 31 37, where it is. Okay, okay, so here it is 31 37. So we'll make combinations. In the second prime list we have to get the prime numbers from this list, the prime number, all the prime numbers from this list into this list. Okay, second prime list. In second prime list, then what we have to do, from second prime list, from this second prime list we have to get the smallest and largest number, and we have to generate a Fibonacci sequence using these two numbers. So the problem is very simple, but it is just lengthy, so we'll discuss. This is the example 2 of the problem. So now we'll see on how we are going to solve this problem. So the first step we have to do is like get two numbers. Okay, so we'll get n1 and n2. Okay, so we'll just get n1 and n2 in like this in step. We'll get the first number 2, we'll get the second number 40, and we'll use these variables. Now what we have to do is generate the prime, this prime list, first prime list, where all the prime numbers from 2 to 40 will be there. Okay, not including 40. So we can take range till 40. So what I have done here is I have used list comprehension in here. For I in range 2 to 40, if 40, okay, if each prime, I have defined the function each prime. If I is prime, append it in the list of first prime. Okay, so we'll see how the function is written. So from math, import square root. I have wrote a function is prime, took a number, the argument is number, for I in range 2 to the square root of n plus 1, converted into integer, and used a if loop. If 0, return false, if not, return true. So this is the fastest, like best way to calculate like the number is prime or not. So you can use this function, you can use this utility function. So if you haven't understood yet, just see it carefully. Okay, so now we have first prime list, this 2 3 5 7 11. Okay, so now what we have to do is make all possible unique combination of numbers from prime numbers list. Okay, in step 1. So we have to generate all possible combinations from prime 1 list and get it in this combination of all prime list. Okay, so what we are going to do is we are going to from iter tools import permutations. So why we are using permutation in here is because you can see, like, if we use combination we'll get like number like 1937. Okay, 19 and 37. So for combinations 19 comma 37 is same as 37 comma 19, so we will not get two different numbers. Instead we will only get 1937. Okay, so we'll see in here if there is 90. Okay, so here it is 1937 and we have 3719. So if we have done combinations we would have only got 19 and 37. Because of this, if you don't understand this, you can refer like some tutorial video on combinations and permutations. So here we have done all the permutations, we have provided an object and also provided like how many elements we are going to combine. Okay, so the permutation returns us tuples in here. So we have converted into list and then joined. Okay, so in tuple we have, if we have got 2 comma 3, we have converted this into list. Okay, and then joined 2 and 3. Okay, so we have got 23 in here. For all the elements we have done this, and then we have like we have joined, right? So we have got this strings. So for making them as integers, what we have done is used a map function to like map them into int again. So this is how we generated combination of all primes. The next step is to find a second prime list like this. Okay, second prime list, you can see in here second prime list, which consists the all the primes from this list. Okay, now 315 is not a prime, so we will not include. Hmm? So we have also used a list comprehension like the first prime here. For I combination of all primes of that list, if I is prime, up will just append it in this list and map it into int. Okay, so we have got the second prime list as this. So we have to find smallest number and the largest number. So we'll use minimum and maximum like function. So the maximum in here is 3719 and the minimum in here is 23. So we'll get the two numbers and we'll input the two numbers in num1 and num2. Then what we'll do is we'll go to sixth, like in the question if you'll see, we'll go to this sixth part, print the last number of Fibonacci series and as an output. Okay, so what will be the last number? Okay, so the last number will be the count of elements in second list. Okay, so the length of this second prime list will be our last. So the length in here, the elements in the second prime list are 34. So we have to calculate Fibonacci of 34, where the first element is 23 and the second element is 3719. Okay, so Fibonacci is where the next number is addition of two numbers. Okay, so we have written a function Fibonacci. I've used dynamic programming in here. So we are like creating a set. If n is present in a set, we are going to return Fibonacci of n. Okay, so this is basically a dynamic programming. We store the values, and if the value is in that list, we get that value, and we don't do the further calculation for that value. So uh, what we are going to do, if n equals 1, okay, so num1 is our smallest number, so we are going to return the value 23, and the num2 is our largest value. If n2 means Fibonacci of 2 will be 3729, the largest number, and we'll calculate Fibonacci, return the value just like this, and we have to calculate length, right? Okay, so we are using set here, so we don't get like repeated what we'll say elements. We'll use length, so f will be 34 here. Okay, so we'll calculate Fibonacci of 32, where num1 will be 23 and the max num, I think it would be 3719. So this is how we can solve the prime Fibonacci numbers. So we'll just run the program. Okay, I've written the program already. So you can see in here we have imported math permutations, took the numbers, defined a function each prime, calculated the first prime list, we have done permutation, got the combination of all prime numbers. In second prime we have done like all the elements which are prime. We have got minimum from the second prime and maximum from the second prime. We also used dynamic programming to calculate Fibonacci sequences, and will like print the last number. So I'll just run this program. I'll just We have input of 2 and 40. Okay, okay, so there's something wrong. So what I was doing was calculating the time to run this program, so we don't get the timeout error. Okay, so using dp we don't get the timeout error. We just again input the values. Okay, just so we have got 131580066689, which I think would be the value we should be getting, like this. Okay, so this is our answer. So you can see we have got our answer. Okay, so if you like this video, please consider subscribing, and thank you.